Hi everyone, this is Dr. Poe, and this is the second example of another way to do stoichiometry. And so, as we discussed in the first video, the real goal here is before we start the problem, we write out our two things that we absolutely will use, and that's the mole ratio, which comes from the balanced chemical equation, and our given, which comes directly from the problem. Okay, so this is just a different form of the same example. In this problem, we're solving for what mass of S8 will be produced from 4.72 moles of Ag2S. So if you'd like to challenge yourself, go ahead and pause the video and figure out the given and the mole ratio for this problem, and then come back. Okay, so the given from this problem is 4.72 moles of Ag2S. And our mole ratio here is we're looking at Ag2S and we're looking at S8. S8 doesn't have a number in front of it, so we know that that's 1. So we know that this is 1 mole of S8 equals 8 moles of Ag2S. Okay, and the reason we're writing out these two pieces of information from the problem specifically is because these are the two pieces of information that we know we will absolutely have to use, guaranteed, in our formula. The molecular weights we only really need based on this particular question. And remember that there's 4 types of questions. There's moles, there's grams to moles, there's moles to grams, and there's grams to grams. So the first example in this series that I did was an example of you were given grams and you had to get grams of something else. Okay, so we're using our given and our mole ratio, and we absolutely have to use those two things. And our first goal number 1, we want to get the number of moles of the given, and then our goal number 2 is to use the mole ratio. So why do we need to get moles? We need to get moles of the given so that we can use our mole ratio. Okay, so from here we've already identified the given and the mole ratio. Might as well identify what we want as well, and we want what is the mass of S8. So mass is going to be in grams, so what's the number of grams of S8 that we can get when we're given 4.72 moles? A really weird number of moles of Ag2S. Okay, so the first thing that we write down in this very first box right here is our given. 4.72 moles of Ag2S. Whew, squeeze that in there. Okay, and so now let's pause and let's look at our goals. First goal is to get the number of moles of the given. So we have number of moles of the given. This is the given, and it's already in moles, so let's not do any more math there. It's already in moles, so that's a huge check. Done. Okay, so now we're going to go to goal number 2. Use the mole ratio. So in this example, we totally do not need the molecular weight of the given. Why would we need the molecular weight of the given? We would need that in order to get number of moles. If we have number of moles, skip it, don't need it. We already have moles. And so the reason that we need moles right here is so that we can cancel those moles in the mole ratio. So we're going to put our 8 moles of Ag2S on the bottom, and because this is moles and that's moles, and this is Ag2S and that's Ag2S, then these two are going to cancel because they're exactly the same. The chemical's the same and the unit is the same. Boom. And what goes on the top in our mole ratio? That's going to be 1 mole of S8, right? Because we're just copying it down verbatim. 8 moles of Ag2S went on the bottom, and that equals 1 moles of S8 that goes on the top. So now our units are moles of S8, and we didn't even need to use the molecular weight. Huh, go figure. Isn't that funny? Okay, so but what do we want? We want the number of grams of S8, and right now we have the number of moles of S8. So how do we get from moles to grams of the same compound? And the answer to that, my friends, is to use the molecular weight of S8. So you can go ahead and figure that out. Pause the video and come back if you'd like to challenge yourself. So that's 8 times 37.02 or something similar to that. 256.56 grams of S8. And remember, for the molecular weight, it's always per 1 mole of S8. Everything from the periodic table is per 1 mole. Where the moles can be a different number other than 1 is in the balanced chemical equation, in which case we just write those numbers down exactly as we see them. Okay, so now moles of S8 on the bottom cancel with moles of S8 on the top. And now our units are grams of S8, which is what we want. So we're all done. We don't even need this other part of the ladder there. Fantastic. So go ahead and multiply 4.72 times 256.56, divide by 8, and we will get our answer. Okay, so our answer is 151.37 grams of S8 is our final answer there. So as you can see here, we use the mole ratio and the molecular weight of S8, and here's where the given always goes. In this one, when we're given moles and we want grams, you don't have to use the molecular weight of the given at all. Because if the given is in moles, you can go straight to the mole-mole ratio. So this is just a further example that you don't always have to use the molecular weight, but you are always going to use the value of the given, which you write first. And then your first goal is to get number of moles of that given. And then your second goal is to use the mole-mole ratio. Yeah, so I hope that this has been helpful.